So we've talked about adding a node at the end of the list and how to add one at the beginning of the list. But what if we want to create our list in some sort of sorted order? So look at the example I have on the screen. I have a list with elements 5, 7, and 21, and they're all in sorted order. So if I want to add the number 3, it will go at the beginning of the list. If I want to add the number 22, it will go at the end of the list. And if I want to add the number 6, it's going to go between the nodes 5 and 7. So there's really 3 different conditions that we have to code for, right? Beginning of the list, end of the list, or somewhere inside the list. So let's scroll down to our add to list function, and I'm going to uncomment that. So let's first consider adding to the beginning of the list. We already learned how to do that, but when the user wants to enter or add to the list the number 3, we'll hop into our add to list. We'll create the new node with the number 3. We're going to test if there is not a head, and there is a head. So now in the else is where we want to code for the 3 different scenarios. So first we need to test, is the element we're adding less than the element that head is pointing to? And that's going to be true. 3 is definitely less than 5. So it's going to go in that position. So I'll say if num is less than head num, then I know that's where I want to go. And so from the previous video, I'll take these 2 statements and paste them right there. So if num is less than the number that head's pointing to, we're going to set new nodes next to head, and then we'll set head to new node. So in memory, it would look like new nodes next would be pointing there, and then we'll update head to point there. And of course, we'll update the local variable head and then return it to main to update the main head. So if it doesn't go at the beginning, then we have to loop and look at all the nodes to see where it's going to go. So it's either going to go somewhere in the list or at the end of the list. So we'll say else, and then we can loop. We want to loop while the new node is less than the next node, or we reach the end of the list. So we're going to need to create a few different variables to hold that information. So I have my current node, and then I'm going to also need to keep track of a previous node. And so when I hop into here, I'm actually going to set current node to head, and then this will still work. I'll say if num is less than head's num, I'll set new node next to head, and then head to the new node. Else, while, and I want to check, is the current node num, well, that's less than num and current node. Because once I get to null, I'm done. And this may run into a problem, right? If current node is null, this is going to give us a runtime error. So I'm going to really take advantage of short circuit evaluation in this case, and I'm going to say while current node, meaning there's something that current node is pointing to, and current node num is less than num. Because that way, when I rearrange it this way, if this is false, this will not execute and I won't get an error. So while that's true, I'm going to set current node to current node next. But what we're going to want to do is keep track of what the current node was before we update current node. And so we're going to set that in previous node. We'll set previous node to current node. So when we add the number 6, 6 will go right between 5 and 7. So I'm going to update previous node to contain 5, and then current node will have 7. So then I'm going to have to update new nodes next to where current node is pointing, right? And then I'm going to have to set previous nodes next to the new node. That will eliminate the connection between the nodes 5 and 7. So when my while loop fails, that means current node is either null or I found a place to put it in the list. So I'll check if not current node, that means that current node is null. I'm going to set previous node next to the new node. And I've already updated new nodes next to be null up here, so I don't have to worry about that. So that will be the new end of the list. If there is a current node, then that means I've found a place where it will go. So for the example of 6, my current node will contain 7, and I'll need to put the 6 between the 5 and the 7. In that case, I'll say else new node next. New nodes next is going to be set to current node. And then previous nodes next will be set to new node. Okay, so previous new nodes next, that's the blue 6. The next will be set to current node. And then the previous node, which contains 5, its next will be set to new node. And that is how that connection will be made. So I'm going to go ahead and delete all of this. And let's run it, and hopefully it will work. So I am getting a previous node maybe uninitialized because there could be an instance where previous node isn't updated. If the while loop doesn't execute, then previous node will not have anything in it. So what we'll do is when we jump into this else, we'll go ahead and set previous node to current node. And then we'll loop through the list, updating previous node and current node, and that way previous node has an address in it. So I'll go ahead and stop this and rerun, enter an integer, and I'll go ahead and do the same integers that we have in our example, but I'll put them in random order. So I'll enter a 7, then I'll go ahead and enter my 3, and then I'll do my 21, and let's do a 6, and then a 5, and I'll do quit. And you can see that they were all inserted in the correct order.